All right. Getting down to the end, we got just a little bit review after one last topic. That's this last topic I want to talk about, and that's molecules themselves. Not just bonds between two atoms can be polar or not. That was what I wanted you to practice in that last exercise. But the molecule itself may have a total plus side and a total minus side because there's unequal sharing of electrons. That's going to become important to know because if it's got a little bit of a plus side and a little bit of minus, it is now attractive to its neighboring molecules. It's more sticky. It'll be more likely to be a solid or a liquid, not a gas, okay? Unsticky molecules that are nonpolar, they're more likely to be gases. Those that are sticky are more likely to be solids, or at least liquids. So let's see if we can determine this. First of all, a molecule has to be polar if it has to have a polar bond. At least the bonds have to be polar. But that doesn't force it to be a polar molecule. Because if the bonds are polar but they're opposite each other, then the plus and minus sidedness does not occur. So the second one is at least one of the groups on the center atom must be different from the other. There must be a lopsided attraction for electrons. So let's draw a couple of molecules and see if they're polar. Let's start with this one, carbon dioxide, which looks like this. Oop. Okay, carbon dioxide looks like that. It's got two double bond oxygens to the carbon. If I lower this and I look at carbon to oxygen, 2.5 versus 3.4, the difference between those is 0.9. Okay, the 0.9 difference in electronegativities, which we saw here, makes it in the polar range. The CO bond is definitely polar. Okay. Now, there's a quick way you can always determine this, is if the atom is from this upper corner right in here, like nitrogen, oxygen, fluorine, sulfur, chlorine, bromine, this kind of corner, it probably is more likely to be polar unless it's attached to itself, like two oxygens or two nitrogens. So that's a quick and dirty way we can determine if that's got a polar bond. So this definitely has a polar bond. The second one, at least one group on the center atom must be different. Oh, this is not different than this one. These two groups off that center atom are exactly the same. So, so this is polar bonds. Okay, that's true, but identical groups off the center atom. So this cannot be polar. Carbon dioxide is not polar, and that's why it's a gas at room temperature. You breathe it out, it looks like a gas. As a matter of fact, if you try to freeze it, it has to get really cold. That's what dry ice is. And once it's ice, as a solid, you warm it up a little bit, it goes right to the gas phase. It doesn't even make a liquid. It can't be held that tightly. As soon as they're free to break beyond each other, they evaporate. That's what dry ice is CO2. Okay, so that's one substance. Let's do one more, okay? And then you'll have some practice to look at some of the molecules you've been drawing. Let's look at not CO2, but SO2. Okay, sulfur dioxide, not sulfite, SO2 minus, but SO2. If I look at those, I've got 6 electrons from each of these, so that's 18 electrons. So let's put the sulfur in the middle, oxygen's on the outside, 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay? Now, it doesn't quite like that, so 18, is that right? 2, 4, 6, 8, 10, 12, 14, 16, 18. This has 6 plus 12 valence electrons for 18. Yep, that's right. The reason it doesn't like that is because the sulfur is missing some. So I'm going to steal one of these. Oh. Come back. Give it to me. Instead of putting one down here, I'm going to put one up there. Okay, that's my trick. But look what happened to the sulfur. This SO bond is definitely polar. It has a polar bond. And is the center have the same atoms around it? No. So there's one different group is all you need. So SO2 is polar. Okay? So you're looking for, after you're said and done, does it have a polar bond somewhere and is at least one group different from the others, and then the molecule's polar. If the molecule's polar, it's more likely to be sticky to its neighbors. It's going to be more likely to be a liquid. It's going to be more likely to be a solid, depending on its size. We'll talk about it a little bit later. So that'll give it different properties. Okay, So go practice your whether a molecule is polar or not sheets and problems there.